Hello everyone, welcome to a Uiua programming video. Today I'll be looking at day 9 of 2021 of Advent of Code, and we need to look at this matrix which represents a height map, and the goal of part 1 is to find the low points, and once we've found the low points we need to take 1 plus the height of those low points and then sum them all together to get the final answer. For the test input, we're looking for 15. So I'll take this matrix, put it in the Uiua pad, make it a raw string, and then we'll do our input parsing. So we'll again be using partition, and in this case we want to again parse the number, and we want to do it by not equal to the new line character. So just as a reminder, the yellow is these modifiers. So we're basically saying give me this mask where the input is not equal to the new line character, and by is saying keep the last argument, so the raw string is still there on the bottom of the stack. And then we're using partition and we're saying to parse. But this is not quite right because we want each of these numbers to be parsed separately, so we will row parse. So this modifier takes the function parse and applies it to each row of the array. In this case, the row being the individual element. So now we have our height map, and we need to look at the neighbors of the array to find the low points. And in this case, we're only looking at the adjacent locations up, down, left, and right, so we don't need to worry about the diagonals. And that is best done with rotations, multidimensional rotations in Uiua. And the constants, a subscript 2 is even built in here, so we have the adjacent neighbor offsets, and we can use this to rotate the array. And in this case, we should do a shift, in fact. So we're doing fill infinity, which means that rather than the elements cycling, sort of looping to the other side, it's just being filled in with infinity. So you can see we've successfully shifted left, up, right, and down if I scroll over. But we still want the original one as well, so we can use by that we already talked about. And now the goal is to, for every position, we want to find the smallest element of this three-dimensional array. And we can do that by using the minimum function, and we want to apply it in between each row of this three-dimensional array, so in between each of these matrices. And that's as simple as reduce minimum. So now what we have is you can check, for example, this 9, the smallest neighbor is 1, and you can see that that's represented here, and that will be the case for any of the positions that you check. And with this, we now want to compare, is the smallest neighbor smaller than the original number? So we can just use a less than here, and then we get our 4 positions that are low points. And we want to keep our original around again because we'll need those heights. So then the goal is, okay, how do we get these 4 heights that we care about? So one thing we could do is get the indices of these ones and then pick those elements out of this second array. So to get indices, we can use the where function, which will get the indices, as it says. And there we have our list of 4 indices. And then we can use pick to get a element from an array, and that gets us the 4 elements we're looking for. And as the description said, we need to add 1. So we can just do it as simple as that. I'll just subscript it because it's sort of, yeah, hard coded. And then we need to sum, which is just a plus reduction. So we can do that. And that is already our part one solution. So pretty nice in Uiua. I think part two is actually even cooler because we need to now find the size of basins, which is the number of locations that all flow down to a low point. So basically in the map we have nines kind of segregating different areas of the map, and we need to find the size of those areas and then take the three largest and multiply their sizes together, and we're looking for 1134. So the really nice thing about Uiua and the partition function is that it has multi-dimensional partitioning sort of, yeah, well, built in. So flood fill, effectively, that's the kind of thing you'd be looking to do. And you could do that by using stencil and sort of iteratively approaching it, but this is much faster, and it's nice to use the built-in functionality. So what we already have here is a two-dimensional partition mask, and we can use partition just like we did before with our input. In this case, I'll just box it to start with, and let me keep the original one. So we can see here that this 213, this is this first group segmented by these nines. Then we have a 4, 3, 2, 1, 0, 4, 2, 1, 2, right? So this is this next group that's segmented. And yeah, so we have all of our groups segmented out. We don't actually care about the elements, we just care about the size. So we can use length to get the number of rows in each of these arrays, and we don't need the original anymore. And now we just need the biggest three from this, so we can sort it, we can reverse it, and we can take three elements, and then rather than adding them together with a plus reduction, we can get the product by doing a multiplication reduction. So that is our part two solution. So I think pretty nice in Uiua, pretty cool that we can use these multi-dimensional rotations. We can use where and pick to get the elements we care about. And then for part two, using this multi-dimensional partition that has the flood fill algorithm built in, I think is very convenient. And we can run it also on the real input. So I'll just drag and drop that in the pad here and load it in. And there we go. 462 and 1.39. Yeah, looks good. So, hope that was interesting. Hope you learned something, and I'll see you in the next one. Thanks for watching.